Welcome back. I'm Tim, and this is 6R. Welcome to our first episode of 6R. We decided we would start off small. Ta-da! And honestly, if it'll fit in the palm of your hand, it's small. And that's what she said. This one comes in a leatherette case. I picked this up on eBay, and it was in great cosmetic shape. Leatherette case. It's got the nice cover. The window is intact. All right, that's important because they're usually loose or cracked or something like that. Again, great cosmetic shape. That's why I picked it up. Got it home, unpacked it. Reels go around, forwards, backwards, no sound. So I said, okay, great. We'll just put the cover back on it, put the leatherette case back on it, put it underneath its little owner's manual, and put it on a shelf in my museum. And that's where it's lived for the last 12 years. Well, somebody lit a fire under my ass and decided that, hey, you know what? We're going to do a YouTube channel and we'll start off small. And this is what we're going to do. We're going to take it to the lab. There's only 4 transistors on this entire thing. There's one here, okay? It's a Sanyo, 2SB 186, all right? And then that second stage is a 2SB 186, and then there are 2 transistors down here, which transistors adjacent to a transformer means it's going to be a push-pull circuit, which is great. You know, the fact that it's got a push-pull circuit, super. That means that somebody actually thought it through when they designed the thing. Putting a push-pull circuit in something as simple as this is what we used to call overkill. So, as I say, 4 transistors, 1 stage, 2 stage, 3rd stage. 3rd stage is push-pull, 2 transistors, and those are 2SB 187s. You know, the circuit board here is only about 1 inch wide, and it's not even 3 inches long. And as you look at the circuitry that's running along here, see all this copper along this edge? Well, that's basically makes contact with the chassis when you run the screws in, when you go to screw the circuit board back in. All right, those are going to make contact with chassis ground. So as I had surmised, there was, well, actually I'm going to finish soldering this capacitor in because quite frankly, this could be part of the audio problem. And as it turns out, it looks to me like there really isn't so much of a foil run between this contact, this lead for the capacitor, and the resistor that it's connected to. It's not no real foil run between it. What they did was they just sort of piggybacked the leads and dropped some solder on them. End up not relying on the circuitry on the board to do the work. No, you got to do the work yourself. Capacitors are what I like to call organic, okay? Because they have a shelf life. They go bad over time. Resistors, not so much. Especially the good old-fashioned flame proofs and stuff like that that started coming out in the, the mid 70s. But still, resistors, I can count on one hand, on 2 fingers, in fact, the number of times I found a resistor that had drifted outside of tolerance. Still no joy. Volume is all the way up. One thing we can do is turn it off and just exercise the record switch. Again, make sure that it falls back. It's in play mode. We'll try one more time. Next, capacitors. I've already replaced 2 of them. One here in the final stage, which was a 5 microfarad, that is. But when I took it out and tested it, it read 30 microfarad, which means it's more of a resistor than a capacitor in that particular part of the circuit. So that was at the final stage. It was the last capacitor in the circuit for the amplifier. So then I replaced the first capacitor in the amplifier, first stage, and still no joy. My rule is you go for the first capacitor, the last capacitor, actually in reverse order, go to the last one, because those are the ones that are going to take the most abuse. The first capacitor, which in both of those cases did not solve the problem here. So it's usually last, first, and biggest. The first one and the last one, both of those are supposed to be 5 microfarad. I tested them before I put them in, always a good idea. And found them to be 4.9, which in 1963 is close enough. So, moving along, going to change out the next capacitor in this chain, which is a 30 microfarad at 3 volts, which incidentally was a dead giveaway on the fact that this was using 2 different voltages. See, when you've got 4 AA's, naturally you just say, oh, 6 volts. Okay, fine. Take the batteries out, hook it up to the bench supply, feed negative to negative and positive to positive, set it for 6 volts, nada. And that's because, and one of the things that actually gave it away was the fact that in rewind, the motor would work. The motor would rewind the tape, but in play mode, it wouldn't go forward. It wouldn't play forward. And so that was like really weird. So I was like, okay, well, maybe the function switch is shot, you know, worn out or corroded or something like that. Or the record switch, which I would assume would defeat the tape speed adjustment while recording, because you wouldn't want to be, you know, messing around with the speed during recording, only during playback, because a rim drive, the speed is going to vary over the run of the tape on the spool. As the take-up spool fills up, the tape tends to pull through faster.
6R is rescue, repair.
Rim drive. What are we talking about? We're talking about the rim of this take-up reel table being driven by a motor shaft centered right between these 2 reel tables. That's the supply side. This is the take-up side. And what ends up happening is that when you hit the play button, that motor shaft starts to spin. And it starts to rub up against the rim of this reel table. Pulls the tape through. Stop. Rewind. Okay, rewind. The motor spins in the same direction, but flips the other way. And it rubs up against this reel table, pulling the tape in the opposite direction. So rim drive is a very cost-effective way of making a tape recorder. And by and large, any tape recorded on a rim drive tape recorder with the same hub size is always going to sound the same. You take that tape and try to play it on a capstan tape recorder, of which there were a lot. It's not going to play at the right speed, because the speed of the tape, the linear speed of the tape through the tape path, is actually going to get faster and faster and faster as this reel fills up with tape. When you play that back on a capstan tape recorder, it's actually going to get slower and slower and slower toward the end of that tape, okay? Because the tape was recorded faster toward the end, but the capstan tape deck is actually going to be playing it at a constant speed. These were not known for that. They weren't meant to, okay? By and large, these things were just used for like talking letters and tapes that you would record and mail to a friend or your grandkids, or they would send you tapes and things like that. But rim drive, again, cost-effective way of creating a tape drive that worked. I'm actually just going to work my way through the circuit. I'm going to do the next capacitor in line. If that one doesn't solve the problem, then I'm going to go after the big one. Bottom line, they all get replaced. Okay? They're all over 60 years old. Okay? I'm over 60 years old, and they replace me. Back in the good old days, capacitors, electrolytics primarily, would have their polarity marked on them, of course. It's a 5 microfarad capacitor. This lead right here is labeled positive. Okay, that's the old capacitor. Newer capacitors, I can't tell you exactly when they started this, but they started marking the capacitors with a negative lead. When you're replacing capacitors, make sure that you know where the positive lead is, or the negative lead in that case, all right? So obviously if the positive is marked, the opposite one, the other one is negative, okay? And that's where the negative one is going to go. I'm gonna be careful not to tug on those wires too much because they are very, very thin. Another thing to do is before you ever even start to work on one of these, then just take multiple pictures at different angles so that you can identify when a wire breaks off while you're working on it, you know where that wire goes. One of the things I like to challenge myself with is working on a circuit like this and not have any wires break, which is an indication that I was very, very careful while working on it, and I had had my coffee, or the third cup. So I'm just trying to get that one lead loose. See, now that felt like something just gave way. So I just broke a wire off of something. Yep, there it is. So now that that wire is loose, I can actually just get back to work on this. I'll worry about that in a little bit. Another little fun thing is you can play with yourself is to see how much solder wick you can get full of solder before you actually have to cut it off. I'm doing it this way, cutting off every little bit, because I'm trying to impress you. It's like, oh, we're very meticulous about keeping the ends neat and all that kind of stuff. It's like, well, it is a little cramped in here, and solder wick that already has solder in it don't wick. All right, so that one's back in there. It's like brain surgery with a chainsaw. You just do it by eye. There it is. Okay, so that capacitor just fell out of there. All right. 30 microfarad at 3 volts. There it is, right there. Okay, now. Okay, get the capacitor checker out. I'm just curious, but you're going to witness this with me. All right, positive lead, because, well, you know, 30 microfarad. And what do we got? Microfarad 97. It's labeled 30. And it's dropping. So we're now down to 87 microfarad on a capacitor that's supposed to be 30. So we'll go find a 30. Probably got a 33, which will work at 6 volts. I'm going to end up using one that's more than 6 volts because 6 in today's technology, a 6 volt capacitor at 30 microfarad, you could fit 3 of them on your pinky fingernail. So where are we at? 22, 33 microfarad at 16 volts. 16. I've got some 50 volt caps in there again too, but those are axial leads. See, these are radials. Yeah, just like your steel belted. All right, but here's the deal. All right, where's that 30? Okay, that's a 30 at 6 volts from 1960 something. Okay, this is an Aiwa TP-60, so it's like could be anywhere from 63 to 66. Okay. This capacitor right next to it is a 33 microfarad at 16 volts. The black one on the left is 16 volts at 33. The right hand side is 30 mic and half the space. So now remember, the negative leg is labeled. It's going to say left-handed. Gosh, these leads are so long. I'm not used to working with long leads, she said. I'm just going to bend those a little bit out of the way just to hold it in so it doesn't fall out. Usually after I solder something new in, I like to leave the leads long because if I'm going to, if for any reason I need to change that out again before I do that, okay, now I can hook this all up, test it out. Still doesn't work. Probably another capacitor bad somewhere. But usually I leave the leads long until I'm done because that way it also gives me something that I can actually attach, you know, a clip lead to in order to maybe do a signal trace or something like that. That's for like bigger projects, but I'm going to leave just enough on there so that I can attach to it if necessary. Now I'm going to check my photograph and reattach that lead, having to just replace that one capacitor. So the wire tinned lead right there, okay, is going to be going to that lug right there on the switch. See if I can manage that. Sort of bend that down a little bit. Bada boom, bada bing. So, now, I'm used to having actual camera people run cameras, zoom in, focus, tilt up, pan left, all that kind of stuff. It's not in the budget. That's hooked up. That's looking sort of right. So I'm going to put this into position and just sort of put some pressure on it to hold it against the circuit and see where we're at. Okay, reels are spinning. I can feel it turning on there. Still no joy. I'm going to go after that 100 mic next. So we've replaced all the capacitors. I mean, for something this old, you're going to replace the capacitors anyway. But I mean, these were way out of tolerance. 100 mic at 6 volts. 280. When it gets to 300, sell. It's supposed to be 30 microfarad, and it hasn't even decided to stop counting yet. 30 microfarad at 6 volts. It's reading roughly 0.002 microfarad. Well, 2 more capacitors. The chances that this one capacitor is the one that is causing failure, I kind of doubt it. If this doesn't fix the problem, then it's got to be a transistor or two. However, what we do have here is this last capacitor is a bypass capacitor to ground. 30 microfarad, 93. Caps that I have replaced from input to output, this one, that one, that one, that one, that one, that one, and that one, and this one over here. Okay? All the caps that came out of here were at least 300% out of tolerance. These are the capacitors that have been replaced, none of which measured correctly. So, and right now it's, it's running.
You see what I'm talking about? When something's that far out of tolerance, I mean 300%, that's when you sell and you get rich. But it doesn't work that way with capacitors. Capacitors that far out of tolerance are going to be more like resistors than capacitors. So in the back of my mind, I'm thinking, okay, well, these things aren't really blocking the DC, the direct current, in this amplifier. They're actually pushing the electrons into those transistors, and this whole thing is meant to operate on like 3 volts, but the biasing of transistors in this genre is just not going to be very tolerant of that excessive current. So I have to be thinking, all right, these transistors might be damaged as a result. I mean, the capacitors are replaced, but now I have to worry about whether or not the transistors have been damaged in the process.
Well, I gotta tell you, it's a lot louder than it used to be. Circuit board screws in there. Make sure that it's making good contact. It could be that so many of these capacitors were so out of tolerance that the circuit board just looked like one big capacitor. Recapped, haven't done the transistors, hoping that the transistors have survived. Reels are spinning. Heard some scratchiness before. Oh yeah, I'm not hearing any audio. I'm tempted to actually just take a signal and inject it into this thing, but of course, mic level is really, really low. Tape head level is even lower than that. It's like 60, 70 dB down. The tape head input to this, which goes through the record switch, in playback mode, it'd be connected to the tape head. The wire broke a while back, so I haven't reattached it because it's so short and moving the board back and forth, pulling the caps out. It should buzz when I touch the input with this. Gain on this thing is probably close to, if you add it all up, it's probably at least 1,000. Not going to be a whole lot of power, obviously, because it's only 1/10 of a watt, but still. Which again is so weird, you know, when you consider, oh, they're using a push-pull amplifier. Like, why? So little power. I mean, you could have done it with a single-ended amplifier. I can get it to make noise, you know, scratching the power to it and, you know, that sort of thing. But I'm gonna have to rig up using my trusty tone generator. We will be injecting a 1 kilohertz tone into this, which is probably the bottom end of the frequency response curve for this little unit. I'm guessing the bottom end might be about 1K. Top end is probably about 3K. So it's not known for fidelity. It's a toy, but there was a lot of executives that used them back in the 60s because executives could afford toys. So I'll go get that adapter. We'll build it up real quick and start injecting some tone.
That said, we're going to inject tone into the various stages of this amplifier and figure out where the limitations are. And we're going to do that in part 2. I want to ask you to be sure to hit that like button and the comments button. We'd love to hear from you. We'd like to know what we did wrong because, you know, can't downplay small beginnings, and your input is very important to us. Also, subscribe. I was totally blown away by the subscriptions that are coming in, and I just want to be able to, you know, entertain you guys and inform you guys as well. Also, be sure to ring my chimes. Huh? What? Oh, notification bell. Never mind. Sorry. Notification bell. You hit that, and then you're going to know when we put something else up. Like part 2, for example, you might want to see that, where we actually fix this thing once and for all. Thanks for watching. Hey, look. This, I know what I'm talking about, okay? But notification bells and, you know, subscription trumpets and, you know, comment, that's all well and good, okay? You know, put it this way, gang. If you're watching this YouTube channel and you really want to see more of it, there's therapy for that. Necessary. Those things, damned if you do and damned if you don't. Welcome back. Shit, I didn't like that.